If you're building anything serious on AWS, then you're in exactly the right place. Today, we're diving deep into the absolute heart of AWS networking: route tables, NAT gateways, and ENIs. Look, getting these right is absolutely critical, because getting them wrong, well, that's where the real trouble starts.
80%. Just let that number hang in the air for a second. What in the world of cloud infrastructure could 80% possibly refer to?
You got it. 80% of production accidents, misconfiguring your route tables, your NAT gateways, your ENIs, that is the #1 reason for downtime, for outages, for those late-night pages. The message here is crystal clear. Mastering what we're about to cover isn't just theory. It's about production survival. Okay, so here's our game plan. We'll start by really unpacking that 80% problem. Then we'll get into route tables. Think of them as the GPS for your VPC. After that, we'll talk about the NAT gateway, which is your secure one-way exit to the internet. Then we're going to spend some really important time on avoiding the common and very costly pitfalls. Next up is the unsung hero of networking, the ENI, or Elastic Network Interface. And finally, we'll put it all together with a complete network blueprint. Let's do this. First up, route tables. The GPS analogy is perfect. If your VPC is a sprawling city, the route table is the system that provides turn-by-turn directions for every single packet of data. It doesn't carry the traffic, but it tells it exactly where it needs to go. It's the fundamental rulebook for everything. Now, for anyone coming from a traditional networking background, a Cisco or Juniper world, this is for you. AWS does things a little differently. Instead of a physical router you can touch, AWS has this concept of an implicit router. Just think of it like a huge software-defined L3 fabric that's just there. And here's the kicker. We don't bind route tables to individual interfaces. Nope, we bind them to entire subnets. It's a really fundamental shift in how you have to think about routing. To really get route tables, you just need to internalize these 4 golden rules. First, every VPC gets a main route table out of the box that acts as the default. Simple enough. Second, a subnet can only have one route table at a time. Period. Third, just like in the physical world, the most specific route always wins. It's called the longest prefix match. And fourth, and you absolutely have to remember this one, route tables only decide the exit path for traffic leaving a subnet. There is no such thing as ingress routing in a VPC. It's just not a thing. Okay, so let's move on to the next piece of the puzzle, the NAT gateway. This is your secure one-way door to the internet for all those resources you need to keep private and locked down, like your databases or your backend application servers. So what is it really? A NAT gateway is a fully managed, highly available AWS service. Its one and only job in life is to perform Source Network Address Translation, or SNAT. It takes traffic from your private stuff, translates its private IP into its own public IP, and sends it on its way. It is strictly for outbound-only traffic. And this shows the flow perfectly. Let's say your private EC2 instance needs to download a patch. That request hits the subnet's route table, which we just talked about. The route table looks at it and says, oh, you're going to the internet? Your next stop is the NAT gateway. The NAT gateway then does its SNAT magic, swapping the private IP for its own public elastic IP. And finally, the internet gateway sends that traffic out to the world. All right, this next section is critical. This is where we get into that 80% problem. This is the danger zone, where tiny mistakes can lead to huge bills and, even worse, production outages. So you're going to want to pay close attention here. This, without a doubt, is the most common and most costly mistake I see people make with NAT gateways. On the left, you see the right way to do it. Your resources in an availability zone use the NAT gateway in that same AZ. But on the right, you see traffic from AZ A crossing over to use a NAT gateway in AZ B. AWS charges for that cross-AZ data transfer, and believe me, at scale, this can add thousands of dollars to your bill that you never saw coming. The golden rule is simple: 1 NAT gateway per availability zone. Okay, here's another number for you. Roughly 55,000. What do you think this one represents? This isn't about cost, but it's a hard limit that can definitely take your applications down if you're not careful. That number? That's the maximum number of concurrent connections a single NAT gateway can handle before you hit what's called port exhaustion. And the symptoms are just maddening. They're totally intermittent. Random API timeouts, DNS queries that just fail for no reason. If you've got a really bursty workload, maybe a bunch of Lambda functions, you can hit this limit. Now, you can scale out by adding more NAT gateways, but the pro move here is to bypass the NAT gateway entirely for AWS services by using VPC endpoints.
That keeps all your traffic on the AWS network, and you just sidestep this problem altogether.
Okay, let's just clear up a few more common misunderstandings real quick. 1. NAT gateways are for outbound traffic only. You can't initiate a connection from the internet to a NAT gateway. 2. Yes, it handles the return traffic for connections that were started from the inside, but that is it. And 3, this means you can never ever use a NAT gateway's public IP address as the endpoint for, say, a web server. It just won't work.
All right, let's talk about the final piece of our puzzle, the Elastic Network Interface, or ENI. This thing is truly the unsung hero of AWS networking. It's the virtual network card that actually glues almost everything we've talked about together. What makes an ENI so special is that it's a persistent object. It's its own thing. It's a virtual network card with its own MAC address and private IP that isn't permanently welded to a specific EC2 instance. You can detach it from one server and reattach it to another. And it's this mobility that makes it so unbelievably powerful. And this mobility unlocks some seriously advanced strategies. You can get instant failover by just moving an ENI from a failed server to a standby one. No DNS changes, no waiting, it's immediate. You can also assign multiple secondary IP addresses to an ENI, which lets you host different services or multiple SSL certificates on a single instance. And for virtual firewalls, this is huge. You use multiple ENIs to create separate security zones, just like you would with a physical box. One for management, one for the WAN, and one for the LAN. All right, we've looked at all the individual parts. Now, let's put them all together and see what a complete best practice network blueprint actually looks like in the wild. This slide nails the core logic perfectly. Just look at the two route tables. The private subnet up top, it routes all local VPC traffic locally. That's the 10.0.0/16 route. But its default route, the 0.0.0/0, points straight to the NAT gateway. Now, contrast that with the public subnet. It handles local traffic the same way, but its default route points to the internet gateway. That one little difference is the entire foundation of a secure VPC design. So let's do a super quick recap. This is your essential checklist. NAT Gateway is for outbound source NAT only. Route tables are bound to subnets, not to instances. Avoid cross-AZ NAT traffic like the plague. It will save you money. Always plan for that 55,000 connection limit on your NAT gateways. The best practice is one NAT gateway per AZ. And finally, use ENIs for powerful, high availability and security patterns. So there you have it. You now have a solid grasp on the components that cause 80% of all production issues. You get the core blueprint for building a single secure VPC. The question is, are you ready for what's next? Are you ready to connect dozens or maybe even hundreds of these VPCs together at enterprise scale with things like Transit Gateway? Well, we'll have to save that for another time.